Hello everyone. It's been a while I have published any content. Been busy with a couple of things and had some other priorities. But I think this is a good time to bounce back and record a couple of series and presentations, etc. I'd like to give a little bit background about myself, then this channel, then this particular presentation is mostly going to be about an incredibly powerful tool. Then in the end, we will see the training roadmap of this channel and the website associated with it. Then we will see how you can give feedback and suggestions for future training materials and presentations. So a little bit about my background. At the moment, I'm a full-time trainer and consultant for Sourcelens, Sydney, Australia. It's my own training and consulting company. And these are some of the positions I've been working over the past 15 years in the reverse order. Or feel free to connect with me over LinkedIn. This is my LinkedIn profile. One of the reasons I was recording and publishing videos was to avoid some repetitive trainings which I was taking in some of the organization I worked before. So I wanted to have a reference where I can direct people, like go and watch and then ask questions, etc. So kind of offloading a little bit to the videos. But after publishing it, I had a lot of people watching it from all over the world, and a lot of business opportunities came through it, such that I could move full time into that business, the training and consulting business. A lot in the Windows internals debugging domain, some in security. Because of that, recently I have started my own training and consulting business, and I wanted to thank you, especially if you are a subscriber to this channel, for all the support you have shown and making this channel a success. Being said that, I would like to get into the topic of the presentation. This is a presentation about time travelers tracing, or IDNA, which was a tool available only inside Microsoft until very recently. One of the most common questions I've been asked in my job interviews or rest of my career after leaving Microsoft is why I left Microsoft. Out of everything, I thought this particular tool was the most precious thing which I had in Microsoft. So what is it first about? So this is a tool which helps for reverse debugging. So before we get into the tool itself, let's see what are the prerequisites of this particular presentation. So I'm not explaining the basic commands and the programs in this presentation, but just about this particular tool. So what is time travelers tracing, or IDNA? So it is a native reverse debugging tool. If you're familiar with IntelliTrace in Visual Studio, which works for .NET, this is a pretty similar tool, but not with Visual Studio, but with Windbg. But it has very similar feature. So you can go back instructions and put breakpoint in the past, etc. So IntelliTrace just works for .NET, but this works for any user mode application. As I mentioned, this was available in Microsoft way back, but Microsoft made it publicly available in the recent past. The tool record the execution of a program and replay it inside Windbg, which we're gonna see shortly. This is a very reliable and stable tool, although it is shown as Windbg preview in Windows 10. It's not really a preview. It's a tool which has at least a decade, more than a decade of maturity and stability. So it is extensively used in Microsoft even today in a lot of difficult scenarios. So this is how you use this tool. It's like shooting a video. You start recording, then do some action in your program, then stop recording, collect the trace, then play that trace inside Windbg. So you can go back and forth, put breakpoint in the past, etc. So this tool has a lot of other implications. There are certain things which is not known at present when you do forward debugging. For example, your stack pointer of a particular local variable. For example, you have a local variable in a function which is going to get executed soon. It's very difficult to predict the actual address of that variable. And literally, it is impossible to predict the pointer which you're going to get from the allocation of a memory. For example, what malloc is going to return. But in this case, because you already executed that part of the program, you already know the pointer. So you can trace who is touching those pointer by going back in time. So let's straight jump into the demo. We're going to see collection and debugging using this particular tool. The first and foremost thing I would like to tell you is that this tool is not downloadable from any Microsoft locations, but you need to install it from the Windows Store. So this is an artificial limitation by Microsoft, and this tool right now, the public version only available for Windows 10 because of this limitation. You can work around this, but that is not the scope of this presentation right now. So right now, if you're using any other version of Windows, this presentation is not applicable to you. You need to upgrade to a latest version of Windows 10. So this is how the tool looks. It's nothing but a revamped version of Windbg. If you have seen before, it's just a flashy version of Windbg. Now a little bit about the program which I'm going to debug here. This is a program which I'm going to debug. It's just a simple C program. It doesn't do much other than allocating some memory, causing an access violation here because of this null pointer, printing a couple of things. So I have already built this program. When you go to File menu, you see all these different options. In that, currently, I'm going to use launch executable. In here, I'm going to select my particular program, which we have seen, which is here. I'm going to execute that program from Windbg. In here, the trick of capturing the trace which we are talking is here. So if I select this particular option, it will start capturing the trace. It will start the recording of the execution of this particular program. So I'm going to check that button, and the trace is going to come here. So I clicked OK. So the program was supposed to crash because of that access violation I showed you before. I'm going to close the program. The program crashed and it has printed some of the statements which I have written. I don't have any new lines, so that's why it's looking a little messy. I close the program. So what I'm going to do is I'm just going to open the trace. I'm going to do a stop debugging because I'm interested in the trace which is just captured. So to open the trace which is captured, it's here. I have a couple of different traces which are captured before. This is the latest one. I have selected and opened that particular trace. So right now, the trace is opened in Windbg. So this is not a live debugging. So this is the Windbg trace which we just captured. This is the execution of the previous program. So the first thing normally to do is to look at the events. So go to the time travel tab here, or you can type the command bang events. So this was an extension, a triple T specific extension, which I was using before. But right now, I happen to see that this extension is removed. So the best bet here is to execute this particular command. So this will show you an overview of all the important things happened while the trace was running, or the program was running while the trace is being captured. So the interesting thing here is this particular exception. Then we we know what is this. It is nothing but load library, loading different DLLs. And this is the termination. This is where the program is terminated, and this is where the program is started. In between, we have this particular exception. So I can just straight away go to that exception by just clicking into it. So my code is loaded because I have a matching PDB. All this PDB loading, the code matching, all this is exactly same as Windbg. There is no surprises or new things there. So if you have any questions on those things, just follow my video series on this topics, the Windbg series. So all these things, just like live debugging, if you're familiar with live debugging with Windbg, this is how it is. So now, if you want, you can go back. So for example, right now you're here in this particular crash, and you can just press this button, step over back. So there's a very good documentation here. Straight away go into the documentation, and you can read more about how time travel is tracing here. So I'm going to click this button just to see, what's uh, what's being happening. So one thing to note is the program is not really executing. There is no console window right now going back and forth printing the statements, but it is just the debugger which is playing the trace. It's just like when you're watching the movie is not actually happening. It's similar to that. So that is one thing, important thing to note here. Because of that reason, you cannot change the execution as well. This execution is just once happened, and you cannot change the course of execution. For example, you cannot put an additional if loop here and change the logic of this program. Because there is no program which is getting executed, just the trace is getting played. So going all the way back, if I want, I can go to the very beginning of this particular main function. And now I can come back just like that. So that is the basic working of this particular trace. So what we have done is we have captured a trace, and we opened that trace in Windbg. We looked at the events, and we gone to a particular event which is an exception. Couple of commands which is interesting here. G minus. G minus is going all the way back to the beginning of the trace. It's like go. It's like F5 in the reverse direction. G is, of course, in the opposite. It'll go forward in time. Then P minus. P minus will go back in time. P is F10. Then T is F11. T minus is F11 backwards. So all those back and forth commands are there. T minus. So for example, in this case, it is going into the printf, I guess. Yeah. So it's gone into the printf. Then another interesting command is bang tt. So time travel, bang time travel. So what it does is you can go to any particular position. For example, if I click here, it is doing a bang tt to this particular position. But normally this is not very useful unless you know which position you want to go to. So that exact position is given by this colon format, B6 colon 49. So the one useful format of this particular command or the extension command is bang tt then the percentage. So for example, 90. So this will go into the 90th percentage of the trace. So for example, the trace is divided into 100%. So this will go into the 90%, which is almost in the end of the trace. This could help you if you're debugging some kind of performance issues, CPU spike, etc. For example, most of the trace will be explaining you what is consuming the CPU. As usual, bang health will give you the summary of the extensions. Um, you can see some examples here. to have more information about that particular command. So indexing is nothing but indexing the trace. So trace is normally very big, just like a video, like I was mentioning before. A trace can be very big, a video can be very big, but you can seek to any position. So indexing is nothing but doing that, just indexing the trace so that you can go to any particular position like this. Now, one more thing I would like to explain before I move to a new program. There is an advantage of knowing certain pointer values ahead of time. So in this particular program, we are crashing here because this particular pointer is null. So in a real world application, this could be anything. In most of the scenarios, you will be wondering how this particular pointer has become null, and it'll be a Herculean task to figure it out. And sometimes it's really impossible from a single dump to figure out how this has become null, especially in the case of 64-bit. If you don't have the stack variables correctly saved, etc. And what we're gonna do is we're gonna look who all are touching this variable in the past. So let's have a look at the registers of this particular crash. So what I have done right now is I have gone to the crash event, like I have done before, like this. So right now I am right on the crashing position. Let's look at what are the registers. So registers EAX equal to null. Looks like EAX is already having the dereferenced value. So let's go back a little bit, UB. So EAX is coming from this particular local variable, which is EBP-14H. So what's the value of EBP? Our EBP is this. So let's see what is minus 14H. So this is the address which I'm interested in. So this is the address I wanted to watch on. I wanted to see who is nullifying that particular address. So what I'm going to do is I'm going to do a BA. So BA is a magic in terms of when it comes to time travelers tracing. I would say this BA has a lot of potential. I have used this particular BA in a variety of scenarios before, and was able to tackle down a lot of different kind of problems like memory leaks, corruptions, crashes, etc. So I'm going to do a read write a break on access breakpoint at this particular address. So whoever is touching that particular address before this particular line, I'm gonna get a break. So this is how it is. So now what I'm going to do is I'm going to do a G minus. So I'm going back in time. So I got one breakpoint, which is pretty much here. Probably that's not what I'm interested in. So that is the reference, pretty much the same line. I'm trying to assign some value into it. So I'm going G minus again. So let's see what is here. UB. So this is not probably pointing to the exact same instruction which is touching this particular variable. That's fine. So sometimes you have to look around a little bit. So in this case, it's just the instruction, one instruction above it. So this particular instruction is, if I look, it is touching that particular address which I'm interested in and assigning a null into it. We just nail down to this particular line which is making this particular pointer null and causing this exception. Another reason for this particular malloc here I have put is this is not freed, so you can troubleshoot issues like memory leak if you find out that a particular pointer is getting leaked, you can check where that pointer is getting allocated and where it is supposed to get freed. Now I just wanted to show you a .NET application which can be debugged using time travelers tracing. So I've been told that there are certain references in internet says that time travelers tracing doesn't work with .NET. It's incorrect. It definitely works with .NET. At least this particular version works with .NET. I'm not going into the capturing part of it. So this is just the basic application. So I'm going to open up the trace for that particular .NET application we have just seen. To see this particular line, I just wanted to go into the 90th percent of this particular trace. So bank double T 90. I'm just going to do a K just to check how it is what I'm thinking it is. Yes, so it is going to be a console read. So that's what I'm looking at here as well, console read. Now I'm going to load the son of strike. Before that, I need to load the symbol for CLR. Reload /f clr.dll. Now dot load by sos clr dot dll. This is enough. So don't worry about this commands. I don't think I have explained this commands before, this, especially this particular command. I have not done any .NET debugging series, which will be coming soon. So basically what I have done is I have loaded the .NET extension for Windbg, the son of strike extension. Now I'm going to type a couple of commands, just to show you that it works. Bang CLR stack. So this is the managed stack. If you want to see the objects, bang dump stack objects. So these are the objects in the stack, this particular stack. So if I want, I can dump any objects if I want. It's a devo and pretty much whatever I do in a typical .NET debugging scenario. As part of the demo, the last thing I wanted to show you is the capture options of this particular tool. The default location where this tool comes up after installation is here, in at least in my case. These are some of the options. You can do a ring buffer. If you don't know when the issue is going to happen, you can keep tracing it. You can mention a file size, output file. You have the option to trace the children. You can launch, this is what we did. We launched a process from the debugger with the capture started. Also, just like a debugger, you can attach to a running process. You can attach to a process and the capture starts from that particular moment in time. So that brings us to the summary of this particular presentation. Overall, a great and powerful reverse debugging tool, which is free and very stable. So that was about the tool. A little bit more about the upcoming series and things like that. These are some of the things which are coming up. So this is going to be a one-off presentation. I don't think I'll be publishing any more presentation on this particular tool because it's same as WinDbg. I have a couple of videos already recorded for processes, threads, etc. Basically Windows internals and stuff like that. There's a .NET internal. A lot of people have requested me to record the .NET internal and debugging series, especially now that the .NET Core has been open source. There's a lot of interest going into it. Networking and cryptography, that was something which I was working in a couple of my projects before. Then sysinternals tool, scenario-based debugging, which is like a crash dump analysis, hang dump analysis, system hangs, etc. I'll be keep updating my roadmap here. So reviews, comments, suggestions, all I normally take from one single location. I would like to take it from one single location. If you don't mind, I would recommend you follow this particular pattern. It's not really useful to me if you update the YouTube commands, which is not really monitored by me actively. If you really need my attention, this is where you need to go. Now, if you think you need more personal attention, this is where you should go. Also, if you think someone will benefit from some of these trainings, it's pretty affordable. I have made it pretty affordable to pretty much everyone. This is available online as well as direct training. So that's it. Thank you for watching. See you next time.